Just one night, all we got. Just one night, all we got. Just one night, all we got. Just one night.
And the team is performed by Alejandro Renteria and Rafael. I'm going to explain the procedure of our problem, where this is a sketch, and we have the time that is 4 hours, and we have the category A and the category B. To get the value of the category A, you have to multiply the velocity, that is 22 miles over hour times 4 hours. And you get 128 miles because the hours get simplified. And then to get the category B, you have to multiply 26 miles over hours times 4 plus 200 miles. You get 304 miles. Then to get the hypotenuse, you have to use the Pythagoras theorem, and then you substitute the value that you get before, and solve, and you get the value of the hypotenuse, that is 229.8484. Then we have to use again the Pythagoras theorem, that is c squared equal to a squared plus b squared. You have to get the derivative of this, and you get 2 times the hypotenuse times the derivative of the hypotenuse respect the time, that is equal to 2 times the category A times the derivative of the category A respect the time, plus 2 times the category B times the derivative of the category B respect the time. And you substitute the value that you get before and solve the equation. Then you have to isolate the derivative of the hypotenuse respect to time. So you have to pass this value dividing this. So you get the derivative of the hypotenuse times respect to time, that is equal to 2,400 over 659.68. And the final value, that is 36.3812 miles over hours.
Implicit differentiation. What is implicit differentiation? The function is called implied when there is a relationship between x and y in such a way that the equation is not explicit to y. Then y is called implied function to x. Y-related rates of change are an example of this type of differentiation. The principal cause is because implicit differentiation is used to calculate a little changes, and the rate of change isn't an explicit function. Y-related rates of change are an example of this type of differentiation. The principal cause is because implicit differentiation is used to calculate a little changes, and the rate of change isn't an explicit function. What related rates of change are? When solving related rates, we figure out the rate at which a quantity is changing in relation to ours to the others. We are finding the rate one thing is changing as the other two.
What are the characteristics of this application of differentiation? It's used to find the velocity about something is in constant changes. It's to find a missing quantity to others about whose rates are not, and uses the first derivative.
As a conclusion, we found practical application of the average rate of change
is used to measure the speed of an object undergoing motion. Is used in various astronomical equations pertaining to rocket science and space travel. Is used to measure the rate of a chemical reaction in chemistry. Is used in various behavioral calculations relating to management and the human psyche.
Just one night, all we got. Just one night, all we got. Just one night, all we got. Just one